That 2% is me. Okay, here we go. The volume of a cube. Now, when I start doing these problems, I start trying to identify variables right away. If I identify all my variables, for some reason, it sometimes triggers something, and I'm able to figure out the pathway out of this problem to get the answer. So it says the volume of a cube. Boom, I'm going to stop right there. I'm like, you know what? I know what the volume of a cube is, so I'm going to write that out. Okay, the volume of a box would be length times width times height, but a cube is a special type of box. Why is a cube a special box? All the sides are the same. Okay, so instead of doing this, I can just say the volume, instead of that, we're going to say the volume equals x to the third power, because length and width and height are all the same, so it'll just be x times x times x, which is x to the third. Okay, and then it says the volume of a cube is decreasing. Oh, decreasing at a rate. Ooh, there's that magic word, rate, volume, rate. Okay, so it's dv over dt. And it's decreasing. It's decreasing at a rate of 10 meters cubed per hour. And I'm gonna keep writing my labels just so I don't forget at the end to label my answer. So it's decreasing. So it's negative 10 meters cubed per hour. All right. And then we have our question: how fast is the total surface area? What surface area? That came out of nowhere. We were talking about volume, you stupid problem. Oh well. Okay. So surface area. What is surface area of a cube?
6 squared.
Yeah, okay, so like if you guys are thinking about a cube, okay, all the sides are equal, right? So if you find the surface or the area of one side, you just have to multiply it by the number of sides there are and how many sides are on a cube. So the surface area or the area of one side would be x squared. And there's 6 sides of those. So our surface area function is 6x squared. Okay, how fast is the total surface area decreasing? Oh, that's like a rate. So we're actually looking for dSA over dt. This is what we're looking for. This is our goal. That is what we're trying to find. Okay. And it's, because it's decreasing, we should get a negative answer when we're done. That's kind of like a check. When the surface area is 54 meters squared. So now we also have a surface area. So the surface area is 54 meters squared. Okay, so how the heck are we going to do this? Well, the biggest thing, this is like the biggest number one question, like thing you got to find when you solve these problems. You have to find the relating equation. The equation that relates all the rates. That's why they call these related rate problems. It has to relate dv over dt to dA over dt. That's all the information we're given. We're given information about the speed at which the volume is changing, and we're given information about the surface area at a certain point in time. We are not told what x equals. Now, that being said, there's probably different ways to solve for this, okay? But because I got the rate of the volume, I want to try to get a dv dt somewhere so I could plug that rate in to find it. So how can we relate volume and surface area? How can we relate that? It's definitely not volume equals surface area, but how can they be related? Now, when I'm looking at, this is what I thought of. When I'm looking at volume and I'm looking at surface area, where is it? Right here. They both have x in common. You see that? So I'm going to do like kind of a system of equations thing here, and I'm going to solve for x for one of these. Doesn't matter which one. I'm going to solve for x, and then I'm going to plug that back into the other equation. So it's almost like a system of equations. We have v equals x to the third, and then surface area equals 6x to the second power. So let's get the x alone with the surface area. You guys do it first before I do it. Go. Get x alone and the surface area equation. Okay, so I got, let's see, SA equals 6x squared. So if I put 6 over here, that 6 is gone. And then I square root it. So x would equal the square root of 1/6 SA. Or you guys can write that as 1/6 SA raised to the 1/2 power. And so what I'm going to do here is I'm just going to take what x equals, that, and I'm going to plug it into this volume formula. So it's v equals 1/6 SA raised to the 1/2 power raised to the third power. That is x to the third. Now this can totally be simplified using a little bit of algebra. this equals 1/6 SA raised to the 3 over 2. So now I have B equals 1 over 6 SA, surface area, raised to the 3 over 2. Can we take the derivative of this with respect to time? Yes, we can. So we get dV over dt is the derivative of the V. And then we take the derivative of this, which is the chain rule. So I'm going to drop the 32 or 3 over 2. We're going to multiply it times 1/6 SA. And then I'm going to take 1 away from 3 over 2. What is 3 over 2 minus 1? Which would be the same as 3 over 2 minus 2 over 2. Minus 2 over 2. It's 1/2. And then I have to multiply this by the derivative of the inside. So we took the derivative of the 3 over 2. Now I have to take the derivative of the inside, the derivative of 1/6 SA. Now SA is one variable. So we have 1/6. The derivative of SA is 1. And then we have to have d SA over dt. Okay, so now we have an equation that has the dv dt and the dSA over dt in it. Then we have an SA, that's our other variable. Do we have numbers for dv dt and SA so that we can find dSA over dt? -10 for that one. For SA we have
54.
All right, so let's plug up everything in. We have -10 equals 3 over 2 times 1/6 times SA, which is 54. And then we're going to take the square root of that. That's what 1/2 means. Times 1/6 dSA over dt. All right, what is 1/6 of 54? It's 9. And what is the square root of 9? So this whole thing is 3. What is 3 times 3 over 2? That'd be 9 over 2. And then we have times 1/6 dSA over dt. I'm just going to rewrite it all because I did a lot of stuff and I don't want to make a mistake. I can cross cancel here. This would be a 3, this would be a 2, and then I would get 3 over 4. So I get -10 equals 3 over 4 dSA over dt. And I multiply both sides by 4, then divide by 3. I get -40 over 3 equals dSA over dt. I almost forgot my units. What would my units be for this? It's meters, and because it's area, it's squared, and it's per hour. That's very important. So the other way to do this would be to solve for x and go through it that way. Just make sure that you don't plug in a number for x before you take the derivative. I guess I'll have to do it that way too and make another video.